Hi, my name is Manoj, and welcome to the summit. Today, we're going to talk about threats targeting Kubernetes and defenses. So, I'm a senior threat researcher with Tigera, and I look at the cloud and Kubernetes attack surfaces. My background has been vulnerability research and malware reverse engineering. So, let's get into slides. Today's agenda is straightforward. I will introduce the topic and then we will talk about the cloud attack surface and various threat actors which are in the wild targeting that attack surface and what are the steps we can do to mitigate those. So currently what we are seeing in terms of threats to the Kubernetes and cloud is external threat vectors are really interested in crypto mining. And a lot of the time they get this initial access with Docker API or misconfigured Kubernetes API or a kubelet API, which is a Kubernetes process on the host. They have the capabilities to escalate privileges within the cluster or within the container, and they can do lateral movement. And time to time, they do make use of unpatched CVEs. So this is the Kubernetes threat matrix, which was released a couple of weeks back by Microsoft. And here are almost 45 techniques that can be used to gain that initial access and then do the privilege escalation, lateral movement, and data exfiltration. So we will, in terms of external threats, so we will double click on that initial access part. If you look at the diagram here, this is a typical Kubernetes cluster where you have a cloud hardware and you have an instance which you have access to, and there is a underlying operating system. And there is a container runtime, which kind of can start or stop containers. And then there is your container at the center, which is the Nginx process. And this container will contain the dependencies needed to run this Nginx process. And Kubernetes is just a vertical, which is managing all these containers and telling container runtime like Docker, Podman, or Cryo to start and stop all these containers. But being the orchestrator, it exposes a lot of APIs so that users can talk to it. So Kubernetes API, kubelet API, which is a process on host itself, Docker API, and usually these are exposed by default to the internet, and you need to secure that. Also, Kubernetes has a way that where you expose your services to the internet. And last but not least, your malicious Docker images. If you are running a container inside this host, you may end up using one of the images hosted on these public repositories like Docker Hub. With that, you will be compromised and attacker will have access to this container and your cluster. This is the attack surface. And just to see how big of an attack surface is, just before this session, I looked at how many open Docker APIs that we can find on Shodan, how many kubelet APIs, that is the Kubernetes process running on particular host, are exposed. And I found almost 500 entries of each. And one of the popular cloud vendor did a study a couple of months back that they were able to reach 50,000 containers from the internet. And we agree with this number as each host or each Docker API will be running multiple containers and number can really add up. So let's jump into our threat actors. So first threat actor is TeamTNT. And TeamTNT really targeted those exposed unsecure kubelet API to gain that initial foothold into Kubernetes. And previously, it targeted Docker interfaces. And the focus for this threat actor seems to be Monero coin mining, as it sees that this is the free compute available on the internet, and it wants to make use of it. And it has capability to do credential theft, like your Cloud IAM roles, your kits, token, your SSH key, and so on and so forth, and command and control capabilities to take them out, and evasion and interesting evasion and DDoS capabilities. we looked at this rootkit, which is dropped by TeamTNT a little bit closely. And this rootkit is basically dynamically compiled. And you can see there are a number of libraries that it needs to be present on container if you need to run this particular rootkit. Just keep this in mind for now. And let's move on to next technique that this threat actor uses. This is LD preload. What LD preload is a Linux functionality. So basically, you set a LD preload to a particular binary on the file system, and when a process runs inside a container, it will load that particular binary or a shared library inside the process memory. And that's what attacker does. As soon as he compromises your container, it sets the preload parameter to attacker controlled library. And as soon as you do a command like ps or ls, in the process memory, attacker library as shown here is loaded. This is basically a DLL on your Windows. It can be executed in memory. And once it is executed, it hooks onto two user mode functions, that is readdir and readdir64 syscall. And it actually filters the output of those syscalls and present the output to you. And just to show you how it does that, this is the code that we looked at. We reverse engineered this particular binary, and we saw that there was a call DLSYM. This kind of locates this particular system call inside the memory, and attacker just needs to override the readdir64 output after that. The impact of this is whenever administrator or someone who is owning that container does the ps or ls command, attacker will filter out his malicious processes. And just to show you how it looks like, here it is. So here is a container running. If you look at this image, I did the ps command and I can see netcat is running here. And after that, I added this malicious binary that I created. And I again did the ps command, and now you can see the netcat is not present there. Basically, this binary has overwritten that readdir64 call. You cannot see it, and this is pretty powerful technique. Another technique that this particular threat actor uses is container breakout technique using a botb framework, which is a red teaming tool available. This technique was posted by Felix Wilhelm on Twitter in 2019. This is as easy it gets. It's a one-liner. An attacker kind of integrated that into his script, and he is now able to break out of container if container is privileged. Here, just to show you a demo, we did the hostname command. And if you see in the red box, I got the host name of the underlying host rather than container. Same stuff for ls command, where I got the files which are available on underlying host instead of container. So this is the example of breaking out of a container using or abusing C group. Just to summarize this threat actor, there are additional capabilities like C2 using tmet, which is another legit binary. And they did the C2 using IRC as well, using Ziggy startups. We talked about LD preload and botb techniques where they try to get out of container. The intent seems to be same, which is Monero coin mining. There are scripts to do the credentials theft and so on and so forth. With that, let's move on to our next threat actor, which is Kinsing malware. This malware targeted Docker APIs to control containers. It didn't do the kubelet yet, but it has an interesting way to spread where the images which were infected by Kinsing were uploaded to Docker Hub. And now any users downloading those or pulling those images and running those are compromised by Kinsing malware. The focus for that malware seems to be same, which is Monero coin mining and credentials theft like TeamTNT. But the interesting thing is, since Kinsing and TeamTNT is targeting same attack surface, TeamTNT had a script where it detected that Kinsing was running, and it would uninstall the Kinsing and then install itself. So TeamTNT was the latest version in that attack chain, and they fought really bad for the same attack surface. So in terms of capabilities, we looked at Kinsing rootkit, and this rootkit also didn't had its symbol stripped, so we could see all the function names inside a binary. And if you can see, there are a lot of functions where they can hide the TCP port, directory names, process names, and so on and so forth. So we found this is a little bit advanced than what TeamTNT had, but the way it worked is almost similar. And the binary is again ELF binary, which is dynamically compiled and needs certain files to be present on container file system. And this is the particular image we got from the internet before it got removed. It had almost 1 million hits at the time, and this is infected with a malware. And this is a tool we used called Dive to look at it, and you can see there is a minor present inside this particular image. So you can see the power and reach of these particular attacks that has taken place. So our last threat actor is Doki, and Doki also kind of targeted exposed Docker APIs. Doki was a backdoor which was previously undetected with an ngrok botnet. And what these guys did, rather than running a crypto miner, they just wanted the access to those containers. So they dropped down this Doki backdoor and just kept it running while all the mining stuff was taken care by Kinsing and TeamTNT. And these guys had a hidden access to all those containers available on the internet. But the way they did the backdooring is kind of interesting, where they use the domain generation algorithm, which is popular trick in the book. They use the novel DGA seed there. If you are not aware of the domain generation algorithm, the way it works is attacker and its malware running inside a compromised container has access to a common seed, that is current seed pair or temperature of the city or even a trending topic on Twitter, and it will generate a pseudo random string out of that. After that, only TLD like .com or .org is concatenated with that random string. A malware can query that domain. But the interesting thing is attacker and malware both will have the same list generated. So what attacker needs to do is generate this list in advance and only register one of that domain. And here Doki backdoor did that. But the seed it used was a Dogecoin API where a particular wallet's last transaction was used as a seed. And here you can see, as we look at the code from Doki backdoor, we could clearly see the Dogecoin API being used here on the top right corner. Now we speak about all these threat actors which are targeting Kubernetes. So here are some mitigation that you can use to protect current and future threats. So first thing is, if you can see bottom image here, there is a normal Alpine container. It contains 135,000 files. On the right side, I created a container using this multi-stage Docker file. It contains only 5 files, and both can run shell applications. So you should be really minifying your attack surface using these scratch images. Your base image will contain only the files which are needed for your applications. That way, it will be very difficult for attackers to run any tool that they want, as there will be no underlying operating system dependencies available. Also, you can go a step further and compile your application as a static for that particular architecture. So in that way, you will have only one file present in your base image. That is really difficult to exploit, even if there is underlying vulnerability in one of dependencies that you use. So moving on, PSP, pod security policies are really powerful feature where you can limit the permissions provided to a container root. Remember, container root is different than your host user. So on the left, you can see the number of permissions by default the root user has. And on the right, I have created one FTP service where the container root has only 4 permissions. So you can really limit your attack surface for container using PSPs. Next thing is your CIS benchmarks. Now you have secured your Docker images and Docker files. It is time to evaluate your configuration, and you can do that. Kubernetes has given us a number of CIS benchmark, which uncovers configuration mistakes. And configuration mistakes look something like this in the image. Right, you can use an open policy agent or you can use a vendor to do that, but make sure that you don't have configuration mistakes in Kubernetes deployment. Next is zero trust. It is really important that whenever you are configuring all this full cloud functionality, you don't expose your APIs to the internet as a north-south traffic. You should be really filtering your north-south traffic. And also, you should be planning to implement east-west policy as well. Because attackers, once they compromise, the first thing they will do is move laterally, and east-west policy can really help here. As you can see on the right, there are some of the policies that we given to secure your Kubernetes deployments, where we only allow kubelet traffic to the host which are containing in the cluster. And below the policy only allows DNS traffic to your core DNS, which is DNS server deployed with Kubernetes. And you should not be allowing external DNS servers like Google's or anything else out of your cluster. Next is you should be having some kind of threat intelligence or SIEM or threat intelligence platform, and have that blocking or monitoring already inside a Kubernetes cluster, so that if there is a chance that somebody else has been compromised and they listed CNC server or that IP or that particular domain is shared with entire world with sticks or taxi format, then you should have that ability to get that information and block that within the cluster. And there are really cool thread feeds and open source projects given in the links here. Mist, OpenCTI, Alien Vault are some of the examples. Having WAF and IDS can really help. You can integrate your Modsec and Envoy together as a sidecar or daemon set within the Kubernetes, and that can provide extra safety to your application. And with Calico, you have power to run Snort engine on container. If your services are sensitive enough, you can do that, and you can really choose your own signature set for that. Another tough nut to crack is machine learning. And for the machine learning to work really well, you really need to log the entire stack. You need to have logs from your services, which are HTTP protocols or L7 logs, your DNS log, your flow logs from the Kubernetes, your process data, what are the processes being spun inside a container, your Kubernetes API, and bytes in and bytes out. And once you have this logging available, you need to build a platform where machine learning can really ingest that data and detect the anomalies. So one of the example is Doki backdoor, where it used a domain generation algorithm that can be detected in this manner, where you see DGA detection using machine learning. And there are many open source and vendors that can do that sort of stuff if you think it is a right solution for you. Docker contained trust, you should be really allowing only images signed by you. That way, you do not give a attacker a chance to run his own images, and those images can be vulnerable and can be used to escape to the host, breaking out of container. So you need to enable Docker container trust and sign your all images. For really sensitive application where you need to security is the prime focus, you can enable syscall filtering using AppArmor or Seccomp profile. On the right side, you can see this is the Seccomp profile where chmod call was used. So you are only allowing this one particular system call. It doesn't matter what permissions are given to the root user, what permission we have inside a container. If you apply this Seccomp profile to a particular container, all it can do is this one particular system call. And this profile can be applied to your pod or deployment or something like that using annotation. So this is Kubernetes pod on the left. And in the annotation section, we applied this Seccomp profile. Now this pod will be able to do only one system call. You should be mindful here because this requires a team which specializes in AppArmor and Seccomp debugging. You need your DevOps skills as well as system skills where you should be able to look at the S trace of your application and debug the issue when it arrives. So last part is container or host isolation. With all that, if attacker ends up compromising your container or host, you need to have a policy ready to kind of isolate and contain the blast radius for the compromise. And the way you would do that is with labels so that you can apply this label to containers and host, and those can be immediately isolated using the policy. This can be done, and a lot of the mitigations that we talked about with Project Calico, we recommend you go and have a look at it. So thank you for joining for this presentation. If you follow all these mitigations that we discussed earlier, none of the threat actors right now, which are in the wild, will be able to compromise or harm your cluster. If you have any questions, any queries or doubts, just reach out to us. We are available on social media, or you can just join Calico Slack channel and let us know your doubts, your use cases, and we'll be glad to take a look at it. So thank you. Thank you very much, folks. Have a good day.